for example number 3, this diagram is in your book, but it is talking about the functions sine x and cosine x. So I don't know if you can see the colors well, but I've got sine x graphed here in blue and then cosine in pink. And what it's asking for is the area between these, but you can see that these overlap, and there's multiple sections of areas that are bounded, and they're all actually the same. And this goes on and on forever because these are both periodic functions that keep going. If you want a really good picture of this, go check out Desmos. Just put these on Desmos and you'll have as many as you want. So what the book tells us is just find the area of one of those sections. Okay, so I'm just going to pick this one as the area I want to find. So I am going to take the integral. In this case, because of the one I've chosen, the sine curve is on top. So we'll do sine of x minus, and the bottom curve is cosine x. Now, what I don't have, that's really going downhill, isn't it? What I don't have is where these intersect. So we need to find these 2 points of intersection. And we're going to do it the same way we did in the last problem, is we're going to set them equal when does sine x equal cosine x. So we get to think back to trig for this one. Yay! Think back to trig that all students take classes. Remember that sine is positive here, but cosine is negative, so sine and cosine cannot be equal in this quadrant or in this quadrant. Now, if we're in this quadrant, you guys know an angle where sine and cosine are equal. It's a 45-degree angle, clearly, okay? That because they're both root 2 over 2. So one of our answers is going to be pi over 4. It's a 45-degree angle. And the other one's going to happen down here because they're both negative root 2 over 2, and so that's going to be 5 pi over 4. So those are our 2 intersection points. So we're going to go from pi over 4 to 5 pi over 4. And now we can just do the antiderivative. Antiderivative of sine is negative cosine. Antiderivative of cosine is just sine. And we need to evaluate from 5 pi over 4 and pi over 4. So we're going to plug these both in and subtract. So we get negative cosine of 5 pi over 4 minus sine 5 pi over 4 minus negative cosine pi over 4 minus sine pi over 4. And again, thinking back to trig, cosine of 5 pi over 4 is going to be negative root 2 over 2, but then we make it negative, so negative root 2 over 2, which will be positive minus root 2 over 2. And then here, this is, again, negative root 2 over 2 minus root 2 over 2. Now, clearly, those two cancel each other out. Negative root 2 over 2 minus root 2 over 2 is going to give us negative 2 over root 2. All right. So our answer is root 2. For some reason, that doesn't seem right. Why not? Because then it's a positive. Minus. Oh, right here. That should have been a negative. Those don't cancel out. I knew that answer wasn't right. This is also 2 over root 2. There. So we end up with root 2 plus root 2, which is 2 root 2. Sorry about that mistake there. All right, let's check out the other one. I had a piece of white chalk. Oh, there it is. Okay. In example 4, they want us to find the area bounded by these 2 curves. And again, this picture is given in the book. F of x is this cubic function. I have it over here in blue. I have this big cubic function. And then g of x is a parabola, and I've got that in pink. And we want to find the area between those. So we are looking for this area and this area. Okay? So we have 2 different sections on this. And you'll notice the way that these graphs work is which function is on top switches. So we actually have to consider them separately. So in this first section here, and the book actually tells you this is negative 2. So from negative 2 to 0, we have to do top curve minus bottom curve. So f of x minus g of x. And that'll give us this region. And then we also need to do this region. So to get that region, we'll take the integral, and again, the book tells you this, from 0 to 2. And this time the top curve is g of x. So g of x, and the bottom curve is f of x. Okay, so sometimes you're going to have to split these up into two different integrations to do this. Okay, now from here it's just algebra and working through it. So I'm not going to take you all the way through this problem. When you do f of x minus g of x, I'm going to kind of shortcut here just because of space considerations. When you do f of x minus g of x, I wrote it down here somewhere. What did I get? 3x cubed minus 12x. Oh, dead spot right there. And then this one from 0 to 2, when you take g of x minus f of x, you get negative 3x cubed plus 12x. You're going to take the antiderivative of both, plug in those numbers, go through that process. And again, just for the sake of space, I'm not going to walk you all the way through that. You should get 24. Okay, so just check your work. If you look at the PDF version of the notes that I've included, I have more work written there. I just know you won't be able to see it all here.